In this video, we will take a look at our next lesson in Unit 2, Chapter 7 on quadratic functions. In this lesson, we're looking at section 7.2, where we were graphing quadratic functions that were given to us in the standard form. The objective of this lesson was to make sure that you knew what to look for in the standard form of the equation in order to be able to draw a reasonable graph. Now, the vocabulary continues to be the same as we had for the very beginning. We're looking at vertex, the axis of symmetry, a maximum, minimum, domain, and range. Those are all words that we continue to use as we study quadratic functions. So the question that is posed for this particular lesson is, how do we draw a sketch when we're given the standard form of the quadratic equation? When we look at it, how do we pull out the necessary information that we need in order to be able to draw a reasonable graph? Now, if you think about why this is harder than the vertex form, well, think about the vertex form for a moment and how easy it is to find the vertex. We simply pull those numbers out, and we know that the vertex is positive P and Q. But when you look at the standard form, we don't know what the vertex is right away. One of the solutions that we could do would be to take the standard form and rearrange it into the vertex form. But as it turns out, this is actually a fairly difficult thing to do algebraically. And at this point in your learning, we're not going to ask you to do it algebraically. Instead, mathematicians thought, it would be much faster to develop a formula. And so here it is. In order to find the vertex, when you're given a quadratic function or equation in standard form, please use the following formula. X is equal to negative b over 2a. Now we're going to jump in and try it in an equation. Here you have been given a function, and it is definitely in the standard form. So our first job is to try to figure out what the vertex is. So the first thing we do is find the vertex. So let's just go to an empty page for a minute and work on that. We use our formula. X is equal to negative b over 2a. Now, b in this situation is a 6, so we write negative, and then we put our number in brackets, 6. Down below we have 2 times a, and once again we put a, which is a negative 1, in a bracket. Then we simplify. We have negative 6 over negative 2, which simplifies further to be 3. So now we know that the x variable of the vertex is 3. So then we need to use that and plug it back into the original equation so that we can figure out what y is. So we plug it in using brackets just to keep everything clean and neat. And then we're going to simplify it. The first number will be 3 squared times the negative, so negative 9, plus 18 minus 8. And when you pull everything together, you find that the y is equal to 1. So your vertex then is 3, 1. So let's take that and put it on the graph, positioning it in the right spot, 3, 1 for our vertex. Second step, I need you to draw the axis of symmetry and label it. So the axis of symmetry, of course, cuts straight through the vertex, and it is a vertical line, so we write x is equal to 3. Next step, find the y-intercept. And here's where the standard form is easy for us because we know that the y-intercept is simply the c term at the end of the equation, so negative 8. So I put my dot down there, and then I find the point that is across the axis of symmetry from this one, straight across, and that would be 6 and negative 8, and I draw myself a line for my quadratic. So there you have it, and how we actually draw a graph when something is given to us in the standard form. The next thing we took a look at in class was a quick word problem, just to get you started on helping to understand how we use quadratic functions in a real-life scenario. Let's take a look at the question that we've been given. Some boaters use red aerial mini flares in an emergency. The path of one brand of flare, when fired at an angle of 70 degrees to the horizontal, is modeled by the function below, where h of t is the height in meters, and t is the time in seconds since the flare was fired. So the first question asks you, what is the maximum height of the flare? Well, if you stop for a moment and consider the function that you've been given, you know that it is a quadratic that opens down. It's fairly skinny because it has that number 9, and it has a vertex of 3 and 83. Now, if you think about what that vertex tells you, you've gone over 3 and up 83, then your maximum height would be 83 meters. The second question, how many seconds before the flare hits the water? Well, we know that it goes to 3 seconds across to get to the highest spot, and that is the axis of symmetry. And so if we go 3 more seconds, we have our flare hitting the water at 6 seconds. And lastly, it says if the flare burns red for 2 seconds, how high is it when it burns out? So what we're looking at is something that has passed a time of 2. And if I substitute that 2 into the t, where it is time in seconds, I should be able to find the height. And so I plug it in. I put in the 2 where there is a t, and I gradually calculate what it is. 2 minus 3 is -1. -1 squared is simply 1. So we will have -9 plus 83, and our answer is 74 meters. Okay, now this is your homework for practicing the graphing using the standard form. Remember to try every question and bring anything that's confusing or doesn't make sense to class, and we'll take a look at it.